Okay, hi everybody. This little video, it's on page 107 of your notes, and it's talking about coordinates that may be inside or outside of a circle. All right. We may not always have a diagram, but it's good to have these pictures just to illustrate the situations that we could encounter. And there's three. You may have a coordinate inside the circle, you may have the coordinate on the edge of the circle, or we might have one outside of the circle. Just some terminology. We're going to be using the letter R for our radius, which is just the distance from the edge to the center. And we're going to be using the letter D to describe the distance from the center to this coordinate. Now, you may have read these already, but for a point inside the circle, you'd expect the distance from the center to be less than the radius. Okay, so in this situation, you'd expect the distance to be less than the radius. For the situation in the middle, the distance and the radius should be exactly the same, right? The point should be on the edge like this. The distance is equal to the radius. And finally, in this last situation, the radius would take us up to here. The distance is a little bit more. We'd expect the distance to be greater than the radius if the coordinate is outside the circle. Okay. So we're going to be using the distance formula as well. If that has passed you by, you can't remember it. Here's the distance formula from coordinate geometry. You may have also seen it written like this: change of x squared, change of y squared. Or you might have just said this is basically just Pythagoras. Okay, however you do it, doesn't really matter. Now, the examples that we're going to look at, we've got a circle. The formula is x minus 3 squared plus y plus 1 squared is 36. And we're going to try and decide whether it's inside, outside, or on the edge of the circle. Now, just comparing it to the equation of the circle, you might need to go back and look at some previous videos for this, but I'm just going to skip it through for now. So the center of this circle is going to be at 3 for the x and minus 1 for the y. And the radius is the square root of this number over here. Square root of 36 is 6. Now, if you want to attempt these by using the distance formula on your own, that might not be a bad idea. You should find that one point is inside, one point is on, and one point is outside. And I think it's in this order. Okay, so if you're feeling pretty confident and you want to just have a go yourself, be my guest, pause the video. I'll be going through it in just a moment. Okay, let's talk about these examples then. So I will do the full worked solution. You can see that it is inside the circle though, so that's quite handy, isn't it? Now, the radius of this circle is 6. That was already established. And what I'm going to need to do is find the distance from this point to this one here. I'm hoping that'll work out as less than 6. According to GeoGebra, which it's already done it for me, the distance should work out as around 5.83. My distance formula looks like this. Change of x squared plus the change of y squared. So I need to look at the x coordinates for the center and the x coordinate for the point over here. Then I need to do the same for the y's. So x values are 3 and 8. That's a change of 5 horizontally. And the y values, minus 1 to minus 4, that's a change of 3. (25). That is 9. I get root 34 from this. Now I know that's less than 6 because root 36 would give me 6. So this is good. I know that it's going to be inside the circle. Let's just check on the calculator that root 34 is in fact 5.83. Oh yeah, of course, 5.83. There we go. Fantastic. There it is. So we can say at this point, because the distance is less than the radius, point is inside the circle. Okay, let's repeat the process for the other 2 points. Let's see what we get. What was the other point? 3 minus 7. 3 minus 7. Over 7. Okay, yeah, on the circle. The radius is still 6. Distance formula, write that out again. Change of x squared. Change of y squared. Change of x, there isn't a change of x. The x values are 3 in both cases, 0. And the y values, I've gone from -1 to 7. That is a change of 6. And again, it doesn't matter if you wrote like -6, it would still work out when you square it as positive 36 anyway. So we are fine. Radius and distance in this case are equal. Therefore, the point should just be on the circle. Therefore, that little 3 dot symbol is a therefore. Therefore, the point is on the circumference of the circle. Cool. And let's have a look at the last one. See what that was. What did we have there? -2, 4. Okay, -2, 4, -2, 4. Okay, so it looks to be outside the circle. Expecting that the distance will be greater than the radius. Oh, I don't know the distance yet. Oops. Radius is 6. The distance, make a bit more space for that. Square root squared y squared. The change in the x values, let's see. So we've gone from 3 to -2. That's a change of 5. And you can write -5 if you're thinking I'll start here and work backwards. Doesn't really matter. And -1 to 4, change of 5. And work out as 25 and another 25, which is 50. And root 50 apparently will be about 7.07. Let's have a check. Root 50. Hey, lovely, fantastic. 7.07. Important part of it is that the distance is greater than the radius. Therefore, the point is outside the circle. Let's have a look at it again. There it is. Okay, wonderful. Cool. So in summary, we're using the distance formula. We're comparing that answer to the radius. And if it's less, it's inside the circle. You can see it changing right now, actually. It's on the circumference. They're equal. And if the point is outside, it's greater than the radius.